In this lesson, we are going to take a look at exponents and square roots to start off your Math 0300 journey. The first thing I've got for you is an example of what we're going to talk about. Sometimes I think it's easier to start with an example and label the parts than to use a bunch of vocabulary words that we're not quite familiar yet. So when we talk about exponents, we are talking about the little bitty number at the top, and each exponent is like a modifier for a base. Now, that exponent tells you how many times to multiply the base by itself. So since that exponent is a 4, I'm going to multiply the 3 by itself 4 times. When I do that, those 3's are called factors. If I multiply all of those 3's together, I get 81. This is called standard form. And then back over here, where we have our base and our exponent, we call this guy exponential form. And I said this just a minute ago, but in case you didn't pick it up, the exponent tells you how many times to multiply the base by itself. When we have a number with an exponent, we call it a power. And that is definitely one of the cases where I feel like an example works best. So let's take a look at 4 with an exponent of 2. Now that 2 is still an exponent. And the 4 is still a base. But all of those together create a power. So our first example, I guess our second example, says to write each product in exponential notation. Remember, exponential notation means we want to write it as a base to with an exponent. Well, it looks like the 4 is being multiplied over and over again. So I think my base will be the 4. And it got multiplied by itself 3 times. So my exponent will be a 3. If I go over to number 2, it looks like my base is a 2 because it's been repeated. If I count, I get 1, 2, 3, 4, 5 times that it has been used as a factor. So that's the same as 2 to the 5th power. Now, I threw in a fraction because I know fractions make most people a little twitchy. And I want to caution you about a pitfall of using exponents with fractions. Now, the 1/2 has been repeated over and over again, so that's going to be my base. And it gets multiplied 1, 2, 3, 4 times. So the temptation is just to put that 4 right out there. But Here is what I want to caution you about. The way that's written says 1 times 1 times 1 times 1 divided by 2, and that is absolutely not the same as what was written in the example. We wanted the 2 4 times also. So to get the 1 and the 2 both used as factors 4 times, we need to go through and use parentheses around that fraction and put the base on the outside. So be careful when you're doing fractions. Make sure you use parentheses to hold everything together. This is another one I wanted to warn you about. Our base is pretty clearly -5. And it has been used as a factor 4 times. When you put this in the calculator, if you put it in just like it is, well, you know what? Let's just go plug it in. -5 to the 4th power. That gives me -625. But remember when you were first learning to multiply negative numbers, you learned that a negative times a negative is a positive, and a negative times a negative is a positive, and a positive times a positive should be a positive. Then we got a negative. So here's what's going on. When we try to write that as the exponential form, what that means is write -5, but the 5 is the only thing that repeats 4 times, not the negative. What you want is to glue that negative to the 5. And to do that, we're going to use parentheses. That will give you what we're looking for. Those parentheses mean the negative sticks with the 5 every time it gets multiplied. So be very, very careful when it comes to negatives and powers. Next, we're supposed to write each as a product of powers, or product of factors. Make sure you're paying attention to what you're doing. If you look at number 1, we don't have parentheses. So that means that negative sign only applies to the first 6, not the last 2. Number 3 is pretty straightforward. We just need 4 8s. Number 2, notice now we've got parentheses holding the negative to the 4. That means this is -4 times -4. Now we're supposed to write these in standard form. These aren't a huge deal. You can take these and plug them into Desmos very easily. You can type them in just like they look, parentheses and all. So -3 quantity squared is 9. If I do 1/3, I'm going to leave my parentheses, and I want a 4 for the exponent. I don't want to mess with that messy decimal, so I'm going to use the little fraction button to change that to a fraction. Now, number 2 does not have parentheses. So I'm going to type it in just like it looks. That gives me -9. And then I want 6 to the 7th power. That gives me 279,936. Now we're going to go take a look at squares and square roots. We say a number or variable, that's a thing now, is squared if it has an exponent of 2. Squared means it can be written as a product of 2 identical factors. So to give you a couple of quick little examples, we say 6 squared. So we mean 6 times 6, so it's a product of 2 identical factors. 9 squared means 9 times 9, and that is a product of identical factors, 2 identical factors. Now we say a quantity is a perfect square if you can write it as a product of identical factors. We need to put a 2 in there. A product of 2 identical factors. So for example, I know 9 can be written as 3 times 3. So yes, 9 is a perfect square. As soon as I go over to 30, well, I know that 4 times 4 is 16. 5 times 5 is 25. And 6 times 6 is 36. 30 is going to fit somewhere in there. So it looks like I cannot write that as a fact or product of 2 identical factors. In fact, I can write it as 6 times 5, but those are not identical factors. So 30 is not a perfect square. So now we're going to go take a look at square roots. We say a quantity is the square root of another if multiplying the number by itself gives the original. When we find the square root, we need to talk about operations. When finding the square root, you are actually using the inverse or the opposite of squaring a quantity. When you solve equations, you use addition and subtraction to undo each other. You use multiply and divide to undo each other. Well, now squaring and taking the square root undo each other. When we talk about square roots, we use what's called, it's this symbol, looks like kind of like a check mark with a roof. It's called a radical. And it means we're going to find the square root of whatever number is underneath it. Could be a number, could be a variable, lots of different things. So what I want to do is try to factor whatever is under the square root and see if I can make it a perfect square. Well, I know that 25 is 5 times 5. That's the same thing as the square root of 5 squared. And we said that squaring and finding the square root were inverses. So that means the radical and the squared cancel each other out, and we're just left with 5. Now, could you go to Desmos and plug that in? Absolutely. But you need to know the why behind it. For the second one, I could write 144 as a product of two 12s. I could write those two 12s as 12 squared. And the square root and the squared are inverse operations. So I'm left with a 12 as the square root for 144. 3 is a little bit different. The factoring is done for you. The idea here is for you still just to recognize that the radical and the squared are inverses of each other. They cancel each other out, and you are left with 8. If you were given maybe the square root of 6, right now, we could factor it. We could factor it into 2 times 3. I don't have a product of identical factors. So that means we would just leave it as the square root of 6. That is the end of a very brief lesson over exponents and square roots.